Good morning to all. I am Subramaniam from SNS College of Technology, working as an assistant professor in automobile department. In this session, we are going to see about the various types of buildings. So we see about the building technology. So in this session, now we see about the advancement of the laser welding technology. Usually, welding technology will be conducted by the help of the arc welding or gas welding and TIG or MIG welding, and another technology is known as the soldering. Obviously, known as welding is joining the two similar parts is known as in the arc welding, and welding the two dissimilar parts by use of the gas welding. But these are usual weldings. Now we see about the advancements of the laser welding technology. In the laser welding technology, we have no electrodes or thing, but due to passing the laser rays, we join the parallel metal with the part metal. So advancement in the laser welding technology have revolutionized various manufacturing industries, offering unparalleled precision, speed, and versatility. Over recent years, significant progress has been made in improving the efficiency, quality, and applicability of the laser welding, making it a preferred method in industries like automotive, aerospace, electronics, and medical devices. One of the key advancements is the fiber laser technology, which has greatly suppressed earlier technologies like carbon dioxide welding and nickel welding. Lasers. Fiber lasers offer higher power density, superior beam quality, and greater energy efficiency, which allows the faster processing speed and deeper welds. They also enable welding of highly refractive materials such as copper, aluminum, and brass, which are previously challenging due to the issues with the beam reflection and energy loss. Another significant innovation is remote laser welding. This uses scanning optics and robotics to perform welding operations from a distance, allowing for precise non-contact welding. Remote laser welding is an ideal for applications requiring high speed production and high levels of automation. It enables faster processing by working on multiple parts simultaneously, thus reducing setup times and increasing overall productivity. The integration of laser hybrid welding has further expanded the capabilities of laser welding by combining laser welding with the traditional methods such as MIG welding, that is metal inert gas welding, or TIG welding, that is tungsten inert gas welding. Hybrid systems deliver deeper penetration, reduced heat distortion, and increased weld quality, especially in thick materials. This hybrid approach is particularly beneficial for the applications demanding both high strength and minimal thermal deformation. In addition, modern laser welding systems now incorporate real-time monitoring and control technologies. These systems use sensor and machine learning algorithms to adjust the parameter during the welding process, ensuring optimal weld quality and minimizing the defects. Such advancements are pushing laser welding towards fully automated systems capable of self-adjustment, error detection, and predictive maintenance. These technological advancements have made laser welding faster, more precise, and adaptable to complex materials, driving efficiency and sustainability in the manufacturing also. So in this session we came to see about the laser welding technology. In the next session we see about the another welding technology. Thank you.